Hello, 7th grade. This is lesson 21. Our objective is what are prime and composite numbers and how do we use them? So first of all, counting numbers greater than 1 are either prime numbers or composite numbers. So every number 2 and bigger we can either classify as a prime number or a composite number. And we determine which one it is by its factors. Now remember, factors are numbers that will multiply together to give you that number. So we just kind of listed here the first few numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And really, since it says greater than 1, not greater than or equal to 1, we're really just looking about the ones 2 on down from there. So notice 2 is 1 times 2, 3 is 1 times 3, 4 is 1 times 4 or 2 times 2. Right? These are the factors. I can use these numbers to get that one. 1 times 5, 1 times 2, or those factors are 1 and 2 and 3 and 6. Right? 1 and 6 are 2 and 3. We'll give you that. 1 and 7 gives you 7. 1 and 8 are 2 and 4. It gives you 8. 1 and 9 or 3 times 3 gives you 9. 1 and 10 or 2 and 5 gives you 10. So these are what we call the factors, because I can use these to multiply together to give me these numbers. So a prime number is a counting number, so like the ones we normally count with, greater than 1, meaning it has to be bigger than 1, whose only factors are 1 and the number itself. So let's just go ahead and mark these up here as either prime or a composite. So I'm looking at number 2, and I'm looking at its factors. Notice there's just 2 factors, 1 and 2. See how that matches there? So I'm going to name this as a prime number. And I'm also noticing 3 is also a prime. Now 4, notice it has 1 and 4, but it also has 2. Notice it says only factors are 1 in itself. So then that would be a composite number. 5 is just 1 and 5, so it's going to be a prime. 6 is 1, 2, 3, and 6, so it's not just 1 and 6, so I'm going to call that composite. 7 is just 1 and 7, so that's prime. 8 is 1, 2, 4, and 8, so that's going to be composite. 9 is also going to be composite. And so is 10. Alright, so it says make a list of prime numbers that are less than 16. So first of all, maybe let's just list those out. Numbers that are less than 16 are going to be, and if we're talking about prime, I'm going to start at 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice it says less than 16. 16 is not less than 16. So what I'm going to do is I'm just going to go through and circle ones that I know are prime. We're talking about 2, 3, 5, and 7. 4 is not, because I know it's 2 times 2. 6 is not, because that's 2 times 3. 8, 2 times 4. 3 times 3, 2 times 5. 11. What numbers multiply to give me 11? Well, just 1 and 11, so it's going to be a prime number. 12. Could be 1 and 12, but also 2 and 6 or 3 and 4, so not that one. 13, I'm thinking 2 is not a factor of it. 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, none of those are factors, so that's going to be just 1 and 13. 14, I can do 1 and 14 or 2 and 7, so no. And 15, I can do 1 and 15 or 3 and 5, so no. So I'm listing all the prime numbers are just going to be 2, 3, 5, 7, 11, and 13. This is all the prime numbers that are less than 16. List the factor pairs for each of these numbers. So I'm trying to think what two numbers will multiply together to give me these numbers. So I'm going to think 1 and 16, 2 and 8, 3, nope, 4 times 4. That's going to be all of my factor pairs for 16. So those pair up together to give me 16. For 17, I have 1 and 17. 2 doesn't. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. None of those work. So it's my only factor pair. 18, I have 1 times 18. I have 2 times 9. 3 times 6. 4 doesn't, and 5 doesn't. So those are going to be all my factor pairs for that one. So notice 16 and 18 are what we call composite numbers, and 17 is a prime number. All right. Example 3 says, list the composite numbers between 41 and 50. So this is a little bit different than example 1, because it said list the prime numbers. Now we are asked to list the composite numbers. So I'm going to go ahead and list these out here. 41. Okay, so I just listed them out here. First of all, I know that 2 times a number will give me even numbers, or all even numbers are 2 times something. So if I'm looking for composite numbers, I'm just looking for something that has more than a couple factors. So I know all my even ones are composite. I'm looking through 49, I know is 7 times 7, so it's also going to be a composite number. And 45 is 15 times 3, or 5 times 9. So those are going to be composite numbers. 41, what you can do is you can go and just check all the numbers smaller than that to see if whenever I divide by them, I can use a calculator. Say it's 41 divided by 10 or 9 or 8. See if any of those are a factor, and I don't believe that any of them are, so that's going to be a prime number. I think it's the same thing with 43 and 47 are all prime numbers. So then my list of composite numbers is going to be 42, 44, 45, 46, 48, and 49. Alright, now when we write a composite number as a product of prime numbers, we are writing what we call the prime factorization. Now the cool thing about prime factorization is that those are unique, meaning that there's exactly one prime factorization for each composite number. Now there's a couple different ways to do that. The one you're probably the most familiar with is what we call a factor tree to find those prime factorizations. And the other way, which we're going to talk about a little bit, is division by primes. So we're going to use a factor tree here for these first ones. So what I'm going to do is I'm going to try to think of 2 numbers that multiply together to give me 30. The first thing I think of is 3 and 10. Since 3 is a prime number, I'm going to circle that. I'm going to move on to 10. 2 numbers that multiply together to give me 10. That is 2 and 5. Those both happen to be prime numbers. So I can write 30 is equal to 2 times 3 times 5. So notice I just got the 2, 3, and 5 from right there. All my circles. And notice I write them from smallest to largest is the proper way to do that. Alright, let's try this next one here. 81. That is 9 times 9. 9 times 9 is 3, or 3 times 3 gives me 9. This is 3 and 3, and though 3 is a prime number, so actually I end up with 4 3s. Now, you could write it like this, 3 times 3 times 3 times 3. But yesterday, we found a better way to do that. We could say 81 is equal to 3 to the 4th power. Because notice there's 1, 2, 3, 4 of those. Alright, now let's go ahead and try this division by primes. So what I'm going to do is I'm going to take this number, I'm going to write it inside 420. I'm going to think of a prime number, the smallest one I can think of that's a factor of that. First thing I think of is 2. So that's going to go into that 1 times 4, 0, bring down the 2, goes in that 1 time, 0, so 110. And then I'm going to take this number and divide it by the smallest prime number I can think of, 2 again. So it doesn't go into 1, but it goes into 11 5 times. It's going to give me 10, subtract, I get 10 here, so it's going to go into that 5 times. So now I have 55, and I know 5 goes into that. So I'm going to divide that by 5, and it goes into that 11 times. And then 11 is itself a prime number, so I'm going to divide by 11 and get 1. So you just keep going until that number on top is just a 1. Then what you've done is you've created its prime factorizations. Notice you have 2 times 2 times 5 times 11. But of course we want to write it with our exponents. This would be 2 squared times 5 times 11. Now this next part says use prime factorization to find the GCF of 18 and 81. Now remember, GCF stands for greatest common factor. So the biggest number that's a factor of both of those. So let's go ahead and find the prime factorization of 18, because we did 81 up here already. So just to save us a little bit of time, we're going to go and find the prime factorization of 18. I think of 2 times 9. 2 is a prime number. 9 is 3 times 3. So what I'm going to do is I'm going to look at the primes up here. There's 4 3s. I'm going to look at the primes down here. 2 times 3 times 3. I'm going to see what numbers they have in common. Notice they both have 2 3s in common. So the GCF is going to equal to, I'm just going to list all of them that they have in common. A 3 in common, right? Another 3 in common. That's all they have in common. So the greatest common factor is going to be 3 times 3, or in this case, 9. All right, your homework, if you didn't already see it, is on page 154 is where it starts. You do all of them from lesson 21, all of them lesson 20, and then 13 more of your choice.